Okay, so today we're going to be graphing the quadratic equations. It is mostly just what we did at the beginning of the week, except that now we have to put all the information on a graph and sketch a little bit better graph. I was sketching graphs in the notes for lesson 10. I just kind of did a real rough sketch up in the corner, and we're just going to do a little bit nicer job. But really, you've done all the hard part in lesson 10. So we're going to be given an equation. You must plot 5 points. Delta is going to make sure you plot 5 points. And they have to be the y-intercept, its reflection, which I'll show you how to do, the 2 roots, and the vertex. So we're going to start out filling out all this same information that we did on lesson 10. So we're going to identify A, B, and C. A is 1, B is -4, and C is 3. Because A is positive, this graph is going to open up. To find the axis of symmetry, we have an equation to use. X equals -b over 2a. So I'm going to substitute a and b into here to find my axis of symmetry. So I get negative, b is -4, divided by 2 times a is 1. So this makes this a +4, divided by 2 is 2. So my equation is x equals 2. Remember that your axis is an equation. You cannot just write 2. It will be wrong if you just write 2. 2 is just a number. We need an equation. So when I get that axis of symmetry, I'm going to sketch that on the graph. So it's a vertical line at 2. And it's not actually part of the graph. It's just going to help guide me in the graphing. The vertex, remember the vertex is, so our graph opens up, right? The vertex is going to be this point right here. Sometimes they call it a turning point. It's where it turns from coming down and then turns and goes back in the other direction. That's my vertex. It has to be somewhere on this line. So for the x coordinate, we just go up here and grab, it's the same x coordinate as my axis. So if my axis is x equals 2, then the x coordinate of my vertex is also 2. And anytime you have an x and you need to find the y, you just substitute x into the equation. So we already got 2. I'm going to put 2 in for all of the x's. 2 squared minus 4 times 2 plus 3. So that's 4 minus 8 plus 3 is -1. So I'm going to put that point on the graph, 2, -1, which is right here. Because I know that the graph opens upward, that point right there is going to be at the bottom of the graph. So it's it's a minimum. Circle the wrong one. It's a minimum. And what is the minimum point? What's the lowest this graph goes? The lowest it goes is -1 because it's going to come down, hit that vertex, and go back up the other direction. So the minimum or lowest point on that graph will be at -1. The roots are where we have to do the most work. The roots are, we have to set the equation equal to 0. They're also the X intercepts. So we have to set the equation equal to 0. Oops, +3. And you have 2 choices. You can do whichever you like better. You can factor it, or you can use quadratic formula. Since this one just has a coefficient of 1, I'm going to factor because it's faster for me. So I'm looking for 2 numbers that multiply to 3 and add to -4. So they're going to have the same sign because they multiply to a positive and they have to add to a negative. So -1 and -3. If we double check, -1 times -3 is +3. And when we add them, -1 plus -3 is -4. So if I set them each equal to 0, if I set this one equal to 0, and solve for x, I get 1. If I set this one equal to 0 and solve for x, I get 3. And I'm going to write those as ordered pairs. So 1, 0, and 3, 0. They're crossing, this is what x equals, so make sure those points go in the x spot. So it's going to cross at 1, 0, and 3, 0. The y-intercept, remember, is just your c, so there's no work to do there. You just look back up. What did you say c was? C is 3. So as a point, a y-intercept, that's 0, 3. So you can see I already have 3 points here. This is my fourth, 0, 3 on the y-axis is right there. We have to plot 5. We need one more point. Parabolas are symmetric, right? So this is the line that cuts it in half. So for each point we have a corresponding point that's symmetric on the other side. If we had a point here, we would have a matching one on the other side. So when I get this y-intercept, if I reflect it over to the other side, I can get the other point. So this is 2, a distance of 2 away from the line. If I go 2 on the other side, I can put the corresponding point over there. And there are my 1, 2, 3, 4, 5 points that I needed for delta. Domain, all parabolas is negative infinity to infinity. I should say all parabolas that open up and down, all parabolas that we will do in this class. The range, so the smallest number, what's the lowest the graph goes, is -1. And what's the highest the graph goes? Well, it goes up forever. There are arrows. It will continue up forever. So that's positive infinity. Okay. So you guys, these notes are brutal. I don't know. I've messed them up so many times. We need a 2 in here. Okay. We need a 2. Okay. So let's see. A equals 2. B equals -4. And C equals 3. Because A is positive, my graph's going to open up. My axis of symmetry, x equals -b. So -4 divided by 2 times A is 2. So that's +4 divided by 4 is 1. So x equals 1. I'm going to graph that as just a dashed line. Remember, it's not actually part of the graph. It just aids us in sketching it. To find the vertex, we take that same x as our x coordinate, and then to find the y coordinate, we substitute that into the equation. So 2 times 1 squared minus 4 times 1 plus 3. 2 minus 4 plus 3 is 1. So 1, 1 is my vertex right there. Ignore the part that says 5 roots. This graph opens up, right? So it has a minimum. The minimum is right here. The lowest the graph goes is 1. So let's do the roots. In the last set of notes, I think I told you that if it starts right here, I'm going to do a really rough sketch that I'm going to later erase. If it goes like this, it's not going to have any roots. It won't have any x-intercepts because it's just going to go up forever. It's never going to cross this x-axis. I want to show you, though, because somebody actually asked about this in one of the assignments or one of the problems today, plus it's just important to know. Let's say we didn't recognize that because we hadn't started graphing yet, and we were going to try to solve for the roots, and we're going to try to use quadratic formula. So I get x equals -b plus or minus the square root of -4 squared minus 4 times 2 times 3. And all of that is over 2 times 2. So when I go to simplify this, I get positive 4 plus or minus the square root. 4 squared is 16 minus 4 times 2 is 8 times 3 is 24 over 4. When I try to simplify the radical, 16 minus 24 is a negative number. So yes, we can simplify it. We practice simplifying with the eyes, but they're imaginary. They're not real points. That means there are no real points where it crosses the x-axis. So there are no roots. So if you go to solve this, we could simplify this answer using imaginary numbers or complex numbers, but it doesn't make an actual x-intercept. They're imaginary. They're not real x-intercepts. So it will never cross the x-axis. The y-intercept is our c, so that's 3. I'm going to reflect that over to get my second point. So that was 1 away. I'm going to reflect it over, and I'll have 1 on the other side right here. So if Delta Math tells you that you have to plot 5 points, that came up with 3. We have to come up with 2 more. So you could, for example, plug 3 in. If we could just plot points like we did when we first learned to graph lines. So say we put 3 in there. 2 times 3 squared minus 4 times 3 plus 3. So that's 18 minus 12 is 6 plus 3 is 9. So when I put 3 in to x, I get 9 for y. That gives me an ordered pair. 3, 9. I can pick whatever I want. I could have picked 5 or 6, but it would have been way off the graph. So that wouldn't have helped me very much. So I have that point, and now again we can use the fact that they're symmetric to find the point on the other side. So if this is 2 away, I can go 2 on the other side and get another point right there. So there's one side and the other. The domain is negative infinity to infinity. The range, the lowest it goes is positive 1, and it goes up forever. Forever is infinity. So this part you don't have to show if you already recognize that the vertex is above the axis and it goes up from there. So if you can recognize from that there won't be any x-intercepts, you don't have to do this part. I just wanted to show you what it looks like if you go to solve and you get a negative radical, what that means for it. So this would be a really great place for you. We've done 2 together now. This would be a great place for you to pause the video and see how much of this you can fill in on your own before you resume and come back and check your work. So I'm going to give you a second. Press pause. Press pause. Okay. I don't know how many of you listened to me, but that's okay. So A equals negative 1, B is negative 2, and C is 8. Because A is negative this time, my graph is going to open down. So it's going to go this way. My axis of symmetry, X equals negative B, which is negative 2, divided by 2A. And A is negative 1. So that makes that positive 2 divided by negative 1. Positive 2 divided by negative 1 is negative 2. So X equals negative 2. Okay, so I'm going to put that on my graph. Here's the axis of symmetry at negative 2. To find the vertex, we're going to use that for our x coordinate. And then to find the y coordinate, we're going to plug that negative 2 in for all of these x's up here. So we have a negative on the outside, negative 2 squared minus 2 times negative 2 plus 8. Negative 2 squared is positive 4, but then you have this negative on the outside, which is going to make that negative 4. Plus 4, and then plus 8. So 0 and 8 is 8. Okay, so our vertex is at -2, 8. Because it opens down, that vertex right there, that's the highest point on the graph. So this graph has a maximum. There's no minimum because the graph continues down forever. How high is that maximum point? How high does it reach? It reaches up to 8. Now we need to find the roots. I'm going to, I guess I could do it right here. So I'm going to set it equal to 0. So I would never, ever, and I told you this in the starter the other day, I would never try to factor when you have a negative right here. It's generally never goes well. So we're going to use quadratic formula. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's +2 plus and minus the square root of 4 plus 4 times 1 is 4 times 8 is 32 over -2. So x equals, if I add these, I get 36 and then take the square root. The square root of 36 is 6. So I'm going to split it into my two solutions. The first one will be 2 plus 6 divided by -2. And the other one will be the 2 minus, again, this equals 6. So 2 minus 6 over -2. 2 plus 6 is 8. Divided by -2 is -4. 2 minus 6 is -4. Divided by -2 is +2. So I'm going to write those two roots as X intercepts. -4, 0, and 2, 0. You guys, this is the long part, right? The rest of it doesn't take so long. This is the part that I know takes a long time. So I'm going to put those points on there. -4, 0 is right here, and 2, 0 is over here. So there are 3 of my 5 points that I need. My fourth point is the y-intercept, which is C. So if you look back up here, that's 8. So 0, 8 is where it crosses the y-axis. Oh, did I screw that other one up, you guys? Oh, look what happened. See, I told you these notes have been a mess. I made a mistake way back here, which you guys would have shown me if we were in class together, wouldn't you? So I'm going to have to delete a bunch of stuff. I would go back and start over, but I'm not going to resolve all this. Okay. Let's erase this too while we're at it. Did you catch me? Did you just assume that if you had tried it before that I was right and you were wrong? Okay. This is -2 right here. So 2 divided by -2 is -1. So the vertex is at -1. And then if I substitute that in, I get -1 plus 2 plus 8 is 9. So I knew it was wrong because I'm not going to have a point and the y-intercept next to each other. The vertex has to be the highest point or the lowest point. It's not going to be equal to another point. It's not going to be next to another point. So the vertex is at -1, 9 right here. And the axis of symmetry. If these notes weren't already being so challenging for me, if I hadn't already screwed up so much, I would redo this one. But you can take this, right? You're good. Okay, so there's 4 of my points. I have to find the 5th point. So I take that y-intercept that I found and I reflect it across the axis. So I get a point over there. And now I have 1, 2, 3, 4, 5 points. And it opens down just like it should. The domain is negative infinity to infinity. And the range, so what's the lowest this one goes? This one goes down forever. There is not a lowest point. It continues on forever. So it goes down to negative infinity. And then the upper, the biggest number or the highest point, what's the highest it goes? The highest it goes is 9.